Sample space. Sample spaces. According to our planner over there, it says probability tree diagram. So I'm guessing sample spaces has something to do with probability. Well, a sample space is a set of all outcomes in a probability event. Everything that could happen. We have been dealing with, as you write this down, we've been dealing with a single event. Drawing one marble out of the bag. Flipping a coin. Today we're going to be putting combination probability together and showing all the outcomes that are possible. For instance, we may flip a coin and draw a marble out of the bag. And you win if you get tails and a blue marble.
It's like a chance.
Right. Chance. Okay? All right. Now, we use a tree diagram sometimes to show tree diagrams are used to show all the outcomes possible. And it's just like we've been saying. Looks like a tree. Looks kind of like our prime factorization tree, doesn't it? Kind of, but don't think prime factorization. It just looks like it in diagram form because we're not doing prime factorization today. We're doing probability outcomes. Probability outcomes, finding the sample space. Now, folks, sometimes you will see the tree going sideways. Now these squigglies are just blah, blah, blahs. You know that, right? Okay? Sometimes the trees go sideways. One year I messed up and taught just the trees going up and down, and guess what they did on the tax test?
Sideways.
They put them sideways and my classes freaked out. They went, I forgot to show them that, hey, they can sometimes go sideways and it's still the tree diagram. They just took it and went, it's that easy, okay? All righty. All right, now we're going to save this one for later. Okay, we'll save this one for later. Let's come over and do this one. I would like for you to draw the dice and draw the spinner, but don't worry about drawing or writing all the words. It takes too long. Some of y'all write so slow, it'd be tomorrow at noon before we got
Thanksgiving break.
All right, so draw, and if you can't draw a cube, it's very easy. Make a square, angle, angle, connect, down and angle over. Very easy. Make a square. Angle, angle. Connect. Down and angle. And you got one. And then put your dot and your 3 dots or 2 dots, however many dots you want to put on it to make it look like a number cube.
Yes.
Draw a spinner. Matt, you're too close to the camera, son. Okay. Thank you. Draw the spinner, Tues. Put black, blue, red, and green. And we're going to think in terms of winning. Remember, probability, I want you to think in terms of winning. Alright? Now this has got to be a combination of things have to happen for us to win. For instance, the probability, we got to win if we get a 5 and a green. Okay? But we're going to show all the combinations that can happen when you do two events as one. We're playing the game that you have to roll the dice and spin the spinner to win. And we want to see all the different ways it could happen. All the different outcomes when we roll the dice and spin the spinner. Okay? Everybody ready? Let's start with roll the dice. And it lands on a 1.
We lost.
Lands on a 1. So I'm drawing a 1. It landed on 1. Now, what are all the ways, what are all the outcomes when I spin the spinner? It could land on black, blue, red, or green. So when I roll the 1 and then spin the spinner, it could land on BLA, meaning
Blah.
it could land on BLU. It could land on GR. And it could land on R. Now, this is a 1 up here, y'all. It's not a bar. It's a 1. Does everybody understand that is everything that could happen if we roll a 1? It could be 1 black, 1 blue, 1 green, 1 red. Is there any other combination with 1 possible with this spinner?
No.
Nope, that's it. That's all we got. Alright? We roll the dice and it lands on a 2. Why do you want to skip around? 2. Now, when I spin the spinner, what can happen? Black, blue, green, red. Bar, 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 bar. Right? Good.
Alright.
Alrighty. 3. Black, blue, red, green, red. Bar, 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 and bar. Okay. 4. Y'all probably getting ahead of me now, right? Black, blue, green, red. Bar, 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 and bar. 5. Black, blue, green, red. Bar, 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 and bar. And 6. Black, blue, green, red. Bar, 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 and bar. Is there any more numbers on the 6-sided number cube? Alright, no. What if we had our pop quiz question? Number cube and these. We'd go 7, 8, 9, and 10. Because it was a 10-sided number cube. Alright, but we've got a regular 6-sided one. Now, I got to go back. I should have done it when I was on it, but that's fine. And I got to show 1 BLA, 1 BLU, 1 GRs, 1 R. 2 BLA, 2 BLU, 2 GRs, 2 R. 3 BLA, 3 BLU. I'm showing the combination. Rolling a 1, spinning a black. Rolling a 1, spinning a blue. That's all I'm doing right now. Is finishing out my tree chart. 3 green, 3 red. 4 black, 4 blue, 4 green, 4 red. Bar, 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 bar. Alrighty, and finish this out. Bar, 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 bar. 5 black, 5 blue, 5 green, 5 red, 6 black, 6 blue, 6 green, and 6 red. That is the combination. Brother Ethan, you need to be doing this, dude. You need to be doing this, dude. Or you'll be behind on this stuff. Put me on pause. There you go. You'll look at it in just a minute. All right. Have we listed all the possible outcomes? The outcomes are that one, that one, that one, that one. That, and that. Are any of them identical?
No, sir.
What if you have one that's identical?
You did something wrong.
You did something wrong. Because they're all different outcomes. Wow. Sometimes it's hard to believe that there's that many different outcomes when just rolling the dice and spinning a 4-section spinner. A whole lot in there. Which leads us to, we can know ahead of time how many outcomes we're going to have mathematically even before I draw the tree diagram. Remember our time now, brother. Keep an eye on our time. All right. So, to find the total outcomes ahead of time, multiply choices. Oh, I spelled it wrong. Why am I putting an N in there? Choices times choices is how I put it. Choices times choices. How many possible choices on a number cube? 6. How many on our spinner in this one? 4. Multiply those. We should have 24 combinations possible. Is that what we have here? If I counted all those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 outcomes. So if we want to find the total outcomes to know if I've got the right answer, or enough answers down there, just multiply the choices times the choices. Okay? Some questions may actually ask you, how many outcomes are possible in this probability event? Do you have to do a full-fledged tree diagram to answer that question? No. Choices times choices, there's 24 combinations possible. Boom, you got it. That's a shortcut hint right there. Now, some of them will say, well, how many outcomes do you have? Now draw a tree diagram to show those outcomes. So we got to be ready to do that anyway. All right? New event. Christian, what do you think, bub? New event.
I'll read it.
Read it. Can you? From there? Okay.
Well, use a truck. Is that
Truck, that's right. We're using a truck today.
Is a truck dark?
There you go. Thank you, man. Go ahead, buddy.
Use a truck diagram to
Tree.
use a tree diagram to list all of the possible all of the outfits. All the outfits I can put together with one pair of jeans or one pair of shorts.
I thought he was reading one on the left.
With a white t-shirt or a blue t-shirt or a
Coach.
Kill it.